the polynomial p of x is equal to 5x cubed minus 2x squared plus 3x minus 2. As you can see, it's a cubic polynomial. If we replace x by 1 everywhere in this p of x, we get p of 1 is equal to 5 into 1 cube minus 2 into 1 square plus 3 into 1 minus 2. That gives us 5 into 1 becomes 5 minus 2 into 1 becomes 2 plus 3 into 1 is plus 3 and minus 2. 5 minus 2 gives us 3, 3 plus 3 is 6 and 6 minus 2 is 4. And so we say that the value of p of x at x is equal to 1 is 4. Similarly, if we were to find p of 0, then it's 5 0 cube minus 2 into 0 squared plus 3 into 0 minus 2. Now, all the first three terms will turn and become 0 because anything multiplied by 0 is 0. And so what is left is minus 2, and that's the answer. But now consider the polynomial p of x is equal to x minus 1. And what if we have to find p of 1 in this case? So I'm going to replace x with 1. So p of 1 is 1 minus 1, which is 0. Whenever we get an answer of 0, we have found the 0 of this polynomial. And so the number that we used in place of x becomes 0 of the polynomial. So as p of 1 has become 0, we say that 1 is a 0 of the polynomial p of x. Similarly, you can check whether 2 is the 0 of polynomial q of x is equal to x minus 2. So let's check that. So we will replace x with 2. Okay, so q of 2 is equal to 2 minus 2, that is 0. And since we have got the answer of 0, then yes, 2 is the 0 of this polynomial, because when I used 2 in place of x, I got the answer 0. So then 2 is the 0 of this polynomial. Okay. In general, we say that a 0 of a polynomial p of x is a number c. So we use a variable in place of the number, such that if we put that c number in place of x, we get p of c as 0. You must have observed that 0 of a polynomial x minus 1 is obtained by equating it to 0. For example, if we have to find the 0 of this polynomial x minus 1, we first equate and see that p of x is x minus 1, but let's assume that it's 0. So now p of x is this, and p of x is also this, and then this 2 also becomes equal. So we equate them. X minus 1 is equal to 0, and that gives us x is equal to 1. That means when we put 1 in place of x, we get the value of 0. So the 0 of this polynomial is 1. We say p of x is equal to 0 is a polynomial equation, and 1 is the root of this polynomial equation. Or we can also say that 1 is the 0 of this polynomial equation. So there are two words which are often used. One is roots and one is the 0 of this polynomial equation. Now consider the polynomial 5. It's a constant polynomial. So the variable with it has x to the power of 0. Can you tell what is the 0 of this polynomial? What value of x here, what value of x will make it 0? Let's start with putting p of x as, p of 0. So we will write 5 into 0 raised to 0. But anything raised to 0 is 1. So it gives us 5. If we take 2 in place of x, we get 5 into, this is multiplication, 5 into 2 raised to 0, that gives you again 5 into 1 because 2 raised to 0 is 1, again 5. And so 5x raised to 0 will always give us 5. It has no 0. In fact, a non-zero constant, remember this word, a non-zero constant, any non-zero constant has no 0. There is no 0 for that polynomial. But what about the 0 constant? So let's check out. What about the zeros of a 0 polynomial? That means just the number 0. Now, if we take 0, it could be written as the variable with it could have any power. It could be x raised to power 4, it could be x raised to power 10, it could be x raised to power 100, because when it will multiply with 0, it will become 0. So the power, the variable with x, the variable with 0 can have any power. Okay, it could also be 0x raised to power 1 lakh or 10 lakh or 1 crore. It could be any power with x. It doesn't matter because it's a 0 polynomial. So what about the zeros of this polynomial? What value will I put in x so that it remains 0? So let's see. Let's take it as, suppose the variable x has a degree of 4 and I'm finding p of 1. So 0 into 1 raised to 4, because in place of x now I'll put 1. So 0 into 1 raised to 4 is 0, because anything into 0 is 0. What if in place of 1 there is 2 or 3? So 0 into 2 raised to 4 is also 0. 0 into 3 raised to 4 is also 0. So there are so many values that I can put, infinite values that I can put in place of x, and every time it will turn to become 0. So what is the 0 of this 0 polynomial then? Every real number is the 0 of a 0 polynomial. Now that's interesting because any non-zero constant, as we have looked in the previous slide, has no 0 at all, because no value here in x makes this polynomial 0. It will always remain 5. So it has no 0. However, a 0 polynomial, for a 0 polynomial, every real number is its 0. Now, let's take this example. Check whether minus 2 and 2 are the zeros of this polynomial. So we are going to take minus 2 and put it in the place of x here. And then we are going to take 2 and put it in the place of x here. So if I take let's take positive 2 first. So if we take p of 2, so it becomes 2 plus 2, which is 4. So I don't get a 0 here. But if I take minus 2, then I get minus 2 plus 2 and it becomes 0. So which one of these two is the 0 of this polynomial? Minus 2 is the 0 of this polynomial, because in this case, the answer became 0. So minus 2 is the 0 of this polynomial. Find a 0 of the polynomial 2x plus 1. Now to find the 0, we equate this to 0. So we will do p of x is equal to 2x plus 1, but let us equate p of x is also equal to 0. That means 2x plus 1 is also equal to 0. So we will equate this. 2x plus 1 is equal to 0. That gives us 1 will go to the right hand side, so it will become 2x is equal to minus 1. And then 2 will also go to the right side, so it will become minus 1 upon 2. And therefore, minus 1 upon 2 is the 0 of this polynomial. Okay? Find the 0 of this polynomial now. This is the standard form of a linear polynomial. So to find this, we will first assume that p of x is 0. So let's put p of x as 0. And because p of x is ax plus b and p of x is 0, ax plus b is also equal to 0, and we will equate it. So now what will happen? B will move to the right side, and so ax plus b is equal to 0 will give us ax is equal to minus b, And then a will move down in the denominator because it's here in multiplication, it will go in division. So x is equal to minus b upon a. This is true for all linear equations. The zero of a linear equation will always be minus b upon a. So x is equal to minus b upon a is the only zero of p of x. A linear polynomial has one and only one zero, which is minus b upon a. In this previous case that we have seen, it is a linear polynomial. As you can see, the highest power is 1 with x. And you can see the 0 is in the form of minus b upon a. b is 1 and a is 2, right? So here we have b as 1 and a as 2. So minus b upon a became minus 1 upon 2. That is the 0 of this polynomial. So that is what we find here as well. Verify whether 2 and 0 are the zeros of this polynomial. Now this is a quadratic polynomial because the highest power with x is 2. So let's find out. So we are going to put 2 in place of x and then we will put 0 in place of x. What happens when I put 2 in place of x? So let's find p of 2. It becomes 2 squared minus 2 into 2, which becomes 4. That is 4, 2 squared is 4, and 2 into 2 is also 4. So 4 minus 4 gave us 0. So yes, 2 is the 0 of this polynomial because I got the answer 0. What if I put 0 now? So p of 0 is again 0 squared is 0 and 2 into 0 is also 0. So 0 minus 0 is 0. Then 0 is also the 0 of this polynomial. So we have two zeros here. That concludes that a quadratic equation can have two zeros. A linear equation can have only one zero, while a quadratic equation can have two zeros.